Right. So, late in the day as it is, it gives me great pleasure to present to you somebody who I'm proud to call a friend in astronomy. One of the nicest people I know in astronomy, incredibly artistic, works really well at supporting particularly women and girls in astronomy, has some amazing astrophotography to do. And for people in our club, she has really got people in our club up and running with the talks and workshops she's given with us. You don't want to listen to me anymore. Mary, over to you.
Thank you. Well, I'm so sorry for the delay, everyone. I'll just share my screen and get straight on with the presentation. Tonight, I'm going to hopefully get you all started with astrophotography if you haven't already dabbled. And throughout the talk, I'm going to dispel a few myths that I quite often hear that beginners have been told by astronomers. You can't do imaging unless you have this thing or that thing. And this sort of thing really winds me up because it's just reeks of equipment snobbery, and that's not what I'm about. So throughout the talk tonight, I'm going to try to cram in as much as I can because astrophotography is a huge area. So I'm going to talk about stuff with and without a telescope, primarily focusing on digital SLR photography. And so I'm going to talk about settings that I've used that got me started. And where there are possible limitations in equipment, I'll point out the limitations, but it doesn't mean that you can't get going with stuff. So I've been doing astrophotography now for probably 11 years, maybe a bit earlier if I class my compact camera stuff. So I've made a lot of mistakes over the years. And basically myth number one, you need a complex imaging rig and a telescope to do astrophotography. So a good friend of mine, Bob Bowers, he has this incredible setup in his observatory. And this is the sort of thing people think that you need in order to do photography. And Bob takes some phenomenal images, but you don't need all of this stuff to get going. And, you know, it's great having guide cameras and all of this kind of wiring and expensive mounts and stuff like that. But you could very well invest in all of this and then realize that's not actually the right equipment for the kind of photography that you're into. So I think when you first start off, it's important to go with the mantra of using what you've got, find out where your interests lie, and then invest slowly over time and build up the equipment that you've got. So yeah, I love Bob's imaging and this setup is amazing, but when you first start, this is too much. It's very daunting and it's going to take you forever to figure out what each thing does. So also, this myth about needing a telescope, also not true. I've had a lot of images and time-lapse videos shown on national TV, on the news, on weather station reports. I've had stuff in magazines. I've even had a textbook cover, all of that stuff without a telescope. The stuff I do with a telescope and spend hours on, no one's interested in. What people like that I do is the wide field stuff. So I'm going to start off talking a little bit about that and show you some of the things that I've done with the equipment that I've got. And I'm also going to talk about specific camera settings if you have an entry-level camera like mine. So myth number two, you need an astronomy modded camera. Not true. What you need is a camera. That's basically it. If you don't know what an astronomy modded camera is, it's a digital SLR that's had the infrared block filter removed. So that makes it more sensitive to red wavelengths of light. So if you're taking a picture of the Horsehead Nebula, fantastic. Rosette Nebula, also fantastic. Milky Way also can help you. But if you're also taking pictures of your cat or your children during the day, everything is going to have a pink cast to it. And it's a hindrance. It's an extra processing step that you've got to correct for. And I do have a modded camera, but I never use it for anything other than those specific uses. And I'm going to show you some examples of stuff I have done with the modded camera, but the majority of my photography has been done with one of two Canon 1100Ds that are not modded. Both of them are over 10 years old. Both of them are well over 100,000 shutter fires. So they've seen better days. There's a few miles on the clock with these cameras, but I'm still really blown away by what I managed to do with this very basic camera that you can probably pick up for 60 quid off eBay. The other thing that I've heard beginners being told, when you first buy a budget digital SLR, it will come with an 18 to 55mm kit lens. Somebody told me that a photographer friend of theirs told them that that lens is so rubbish that you might as well throw it in the bin. Everything I've ever had published has been taken with the kit lens, and I'm going to show you some other pictures of stuff I've done with it. There are some flaws to that lens. It is a cheap lens, but you can still do some really good stuff with it. If you have other lenses as well, a really good lens to have for astronomy is the fixed 50mm lens, also sometimes called a prime lens. It just has a focal length of 50mm and that's it. It's got a really low F number, and I'm going to talk about F number in a second when we get to camera settings, but that makes it really good for taking pictures of dark skies and faint objects. I saved up a couple of years ago, finally bought myself a wide angle lens. It's not a super expensive one. By my standards, it was expensive, but it was under £200. And when you think that a high quality wide angle lens is more like £1,200, it was a budget wide angle lens. And I've done a lot of great things with that, but there are some limitations with it. But also this zoom lens cost me, I think, £95 when I first got my camera. It is an original Canon zoom lens, but I've done so much photography with that: aircraft photography, lunar sunrises, moon rises, and things like that. So I use that lens a lot. For astrophotography, you are going to need a tripod, because generally for the wide field stuff, if you're doing long exposures, you want the camera to stay still. And trust me, you can't hold a camera still enough to do, I can't hold a camera still enough to do more than a second without having some kind of motion blur. The other thing that is going to stop you touching the camera and having any camera shake is using a remote shutter cable. So the one that I recommend is the one that you can pick up for £5 or £6. It's unbranded. You plug it into the digital SLR, and instead of touching the camera, you push this button to take a picture. Even better is if your camera is set into continuous mode, you lock that in place and it will just keep taking pictures one after the other. So absolutely essential for astrophotography. If you start doing stuff on a telescope where you are building up longer exposure times, the maximum you can do on this little guy is 30 seconds. And then after that, you go into bulb setting, which is what we don't want to do, particularly not from the UK. So the programmable remote shutter cable will allow you to program longer exposures. But as a beginner, this one does the job. The cheapy one does the job. Another thing that you can do on a budget is to make a little dew heater to stop your lens from fogging up. And basically, I use Poundland hand warmers and an old sock. So it doesn't get much cheaper than that. As well as being really affordable, because it's just basically 2 hand warmers for £1 and an old sock, it also is lightweight. I have mobility problems, so I can't lug heavy equipment. And if you've got a battery powered dew band, you've got batteries to worry about. If you're powering it off a power tank, it's another heavy thing to carry out with you. This works, it does the job. So what I do is cut the end off the old sock, wrap it around the lens, activate the hand warmers and poke them down the sides. Or if you want to get a bit fancier, still using an old sock, I made this one where I made 2 compartments with a little button and a tab so that you can put the hand warmers in it and wrap it around with some Velcro. The beauty of this is that it's big enough that it'll fit round some decent sized telescopes. So still with the pocket hand warmers, it's very stretchy, so you can poke the bigger hand warmers in. It does a great job, and that has got me through 3 hours on a frosty night without any problems. And in the summer, actually, dew is as much of a problem as it is in the winter. If you've got a warm, humid summer's evening, this just works. So it's cheap, it's lightweight. And if you want to know how I made this, the Sky at Night magazine website has a step-by-step guide to that. So in terms of settings, unfortunately, you're going to need your camera to be in manual, because pretty much anything with a budget camera in particular, if you're trying to do stuff on auto at night, it doesn't understand what you're trying to do. The stars are too far away for the focusing sensor to know what you're trying to focus on. It doesn't know what you're trying to do with the f-stop. It's just a hot mess, basically. To be honest, I don't think I use any of these things on my camera. I'd nearly always do everything in manual. So you are going to need it in manual, and that includes manual focus. And the other thing, I'm going to talk about how to focus in a second, but turn off your flash. Make sure that, particularly if you're out with other astronomers, they will not thank you if your camera does this bright flash and ruins their night vision. And the stars are so far away that a flash isn't going to help you. So just make sure you haven't accidentally got a setting where the flash is going to bring itself on. Now, I mentioned continuous shooting, definitely something if you're going to be doing kind of meteor shower photography, or I'm not going to specifically talk about star trails, but star trails are if you're taking lots of pictures that you're going to stack together to create a more detailed image, you need your camera to be on continuous. I have thought that I've done 3 hours of imaging on star trails once, went out, realized I'd accidentally taken it out of continuous and I'd taken exactly one picture of 30 seconds duration, and I hadn't checked that it was carrying on. So I always keep it in continuous now, just so that I don't make that mistake again. But that just means it will keep taking pictures as long as that button is pressed or locked in place. So you don't have to touch the camera. You can walk away, not nudge the tripod, and just keep away from it, really. Now, for most applications with astrophotography, you want the camera to be in the highest possible resolution because we're capturing very faint objects. So that would be RAW because JPEG is heavily compressed. The only kind of times I don't do that is if I'm doing star trails or meteor shower photography, and that is during a meteor shower, I will take between 3,000 and 4,000 pictures a night. And if they're in RAW, that is a lot of disk space, and it's also a lot of processing power on my laptop if I then want to go on and do stuff with those pictures. So certain applications, I think JPEG is actually okay, but for Milky Way photography, kind of anything at all where you're taking pictures of deep sky or you're going to stack together lunar images. I'm going to explain what stacking is in a minute, by the way. So if you don't know what I'm talking about, you will in a moment. RAW is definitely the way to go. And if you're in doubt, just do RAW plus the highest quality JPEG, then you've got both. So you've got both bases covered. I kind of pretty much keep my camera in RAW so that you don't accidentally shoot in JPEG, but I try to just make sure I'm doing the best quality possible for most applications. With camera lenses, the F number, it refers to how wide open the iris will go. So with the kit lens that comes with the camera, basically f3.5 is as low as it will go. That's actually decent. That's okay. I've done a lot of really good stuff with that. If you, like my wide angle lens will only go down to f4.5, which can give me a bit of a hindrance if I'm taking pictures of very faint objects. That one f-stop really makes a difference, but that's what you get when you pay £200 rather than 1,200. But the fixed 50mm lens goes all the way down to f1.8, which means so many more photons of light are going to make it onto your sensor. When I first got this lens, I was so excited that I could do f1.8 that I shot everything at f1.8 and then found out actually that creates more noise. My camera has plenty of noise of its own accord. I don't need to make that worse. But also, if you're taking pictures of like an area of the sky, one of the things that makes astro pictures beautiful is star color. And if you have the F number down too low, you can lose your star color because they're point sources of light and therefore they overexpose quite quickly. So sometimes just adjusting the f-stop up just a little bit to like f2.2 is like the sweet spot where you're getting loads of photons of light, but you're not quite kind of killing your star color and adding even more noise in an already very old camera. When a camera is attached to a telescope, the f-stop isn't there because basically that's a function of the lens, and when you're attached to a telescope, your telescope is the lens, so you won't be able to change the f-stop. But if you're doing wide field stuff, this is specific to the lens that you're using. ISO settings, again, is going to be determined, first of all, by your sky conditions, and they can change even just within one night. So if you've got a night where there's a lot of humidity and moisture in the air, any residual light pollution that you pick up on your pictures is going to be amplified. So sometimes you have to take the ISO down a bit more than you maybe did the previous night. If you've got a lot of light pollution anyway, then you may have to go lower. For me, I did once shoot something at 6400. Not a mistake I'll make twice, that's for sure, because my camera cannot cope with doing that, especially now it's older. When I've got it new, it couldn't deal with 6400. But if you've got a newer camera, then these high ISO settings are almost noise free and you can really push it up. But bear in mind that if you push the ISO up, you're going to be capturing more of the stuff you don't want as well. And I've got some side-by-side comparisons to show you when I do the Milky Way bit. For me, if I'm doing kind of star trails or something like that, I will usually have it at ISO 800 again, because I don't want to lose the star color. 1600 for a faint object. If I'm really struggling to pick up like 3200 at a push, accepting the fact my pictures are going to be very, very noisy. 16 or 800 is around about the kind of sweet spot for my camera. But this is just one of those things you've got to test. You've got to test what the conditions are like from your spot and with your camera, which is why I do test shots at the beginning of every single imaging run that I do. Because as I said, just within the space of 3 hours, you can go from 1600 being okay to not being okay because everything's bright pink because of the moisture in the air. So it's not a hard and fast rule, but in terms of choosing your ISO setting, this is the same principles whether you've got it on a telescope or just with a camera lens. So most of these settings are applicable regardless of whether it's with lenses or a telescope. Now, in terms of focusing the camera, all the old astrophotography books tell you to focus at infinity. Modern digital SLR lenses go to infinity and beyond because that's the way they're tested in production, I believe. Somebody told me. I know nothing about how lenses are produced, but I do know that if you go to infinity, it's not just a little bit out of focus, it is horrifically out of focus, which is why you need to learn to manually focus the camera. And I think this is the only tricky part of astrophotography. And once you've nailed that, you can do anything, like literally anything. So I've actually made a video on how I do this, because in the past I've tried to explain it, but I've actually been able to go out and video what I do. So hopefully that'll help you. I make use of the live view function on my camera. So I point the camera at the brightest star or planet that I can see at that time, press the live view button, and that will bring up the live view screen. I then use the zoom in button. So I zoom in ×5 and ×10, and you'll see there's nothing on the screen here. What I then do is get the focusing ring on my camera and very slowly move it, and eventually the star will start to come into focus. So you can see that if you're massively out of focus, you see nothing on the screen here. Once I get to the focus, I tend to rock back and forth either side until I can get it as pin sharp as possible. And it's really hard to do this because seeing conditions mean that the sky is kind of boiling and the star will be twinkling. So I take my time on that. And I did this with a 50mm lens, so the stars are a little bit bigger, but you can see on the back of the screen, when it's in focus, you can see some stars with that lens. If you do that with the kit lens, you will not see any stars on the back of the camera when you're zoomed out. You just won't. So basically, you've got to just get used to doing this. If you have a fixed 50mm, it's super easy. Same with the zoom lens. The kit lens a little bit more tricky. By far the hardest is the wide angle lens, because the stars are so tiny on the sensor when you've got more sky on the camera sensor. So it's one of those things that when you first start, I think it used to take me 20-25 minutes to get focus. Now, with everything except my wide angle lens, I can do it in a matter of seconds because it's just practice. And once you've got that, you could say you can do anything. You really can. So that's the way that I do it. If you're really struggling with this at night, go out during the day and point at the most distant thing you can see and put a little bit of masking tape on the camera. And when you go out at night, it will be much, much closer and you'll be able to just kind of tweak the focus. It's 100% worth getting it right, because if you quite a little bit out of focus, your stars are going to be bloated and the picture just won't look as good. So it is worth taking the time to get that right. Now, the shutter speed is going to be determined by a number of factors. First of all, what you're imaging, because if you're imaging the moon, you don't want to do 20 seconds. A fraction of a second is plenty. But if you're doing something faint, you're going to want to kind of push that up more. But on a static tripod, like the one I showed you at the beginning, which cost me about $13.99, it's not a fancy tripod at all. It's going to be determined by the focal length of the lens that you're using. There's a tiny piece of maths, but don't panic. If you've never done this before, you're not going to have any idea how long you can take a picture for without your stars trailing with the lenses that you have. If you take the number 600 and divide it by the focal length of that lens, you'll get a number. And that number is a kind of rough ballpark figure, how long you can expose before your stars will trail. So obviously, the bigger the focal length, the shorter the time's going to be. So a couple of worked examples, just this is a ballpark, it's a starting point, it's not a hard and fast rule. I've seen this called the rule of 500. It doesn't matter whether you use 5 or 600, it's a ballpark figure. So if you're using the kit lens that comes with the Canon 1100D, if you take 600 divide by 18, you get 33 seconds. I know for a fact I cannot expose for 33 seconds without star trailing, but it's usually around about 25 or 30. So it's kind of within the right ballpark to get you started with your test shots. If you're using the 50mm lens, you can only do 12 seconds. I generally would do 10 just to be safe, because it's better to underexpose than to realize your stars are trailed, because unless you're doing star trails, you do not want trailing stars at all. If you are using a 300mm lens, you can only go for 2 seconds. Similarly, if your telescope has a focal length of 600mm, you can only do 1 second. And so it goes on. So even when you're talking about your telescope, the rule of 600s is applicable and it'll give you a rough guide. Why is it a rough guide? Well, that's because the stars around the sky move at different speeds. So if this is a almost 12-hour star trails that I shot from my back garden pointing at the celestial pole, at the pole star, in 12 hours, the pole star has only moved that much. The stars near the pole star have only moved this much. So if you do a 30-second shot pointing that way, the stars are going to be points of light. They're not going to be trailed at all. But if you point over to the opposite side of the sky from that, that is the most amount of movement that you get in a given time. Unfortunately, that is exactly where the summer Milky Way is for us in the UK. So if you're doing Milky Way photography and you expose for 33 seconds, you are going to get trailed stars. So just err on the side of caution. It's far, far better to go slightly under on your exposure than it is to have trailed stars, especially if you're going to start getting into image stacking, because if your stars are not round, stacking software doesn't want to know. It's just not interested. So that is why it's not a hard and fast rule. It's just a ballpark for your test shots. And once you've done it once, you will know how long you can do it for. So you only have to do that test once, really, when you try a new focal length. So when you start shooting the pictures, there's normally a hook on the bottom of your tripod. I normally hang something heavy from it. So if I'm going off on location, I hang my camera bag from there. From home, I will normally hang the battery pack that powers my dew heater, something that will stop my cats from headbutting the tripod, first of all, but also any gusts of wind, or if you're out in the street and a lorry goes past, you want to reduce how much shaking you get in your tripod, and just having that anchor is a really good way of getting basically the equivalent of a heavy duty tripod, but with a bag of potatoes hanging from a hook of a 15 quid tripod. It works really well. It does a great job. You can actually bungee it into the ground. If you're on by the lawn, you can actually get a bungee cable and bungee it straight into the grass. Either way, as long as it's held securely, then it will be safe from gusts of wind. So some examples of things that I have done with lenses. First of all, this was done with my kit lens. This is Orion. You'll probably all recognize it. This was taken from Astrofarm back in 2016, where Mark and I went on our mini honeymoon. So this was taken like the day after we got married, or a few days after we got married. And actually the thin cloud in this picture has really helped it, because a little bit of thin cloud sometimes can enhance the star color, and Rigel's very blue, Betelgeuse is very red, and that really shows up in this picture. So yeah, this is just done with the kit lens, not an expensive lens, and the pictures look really cool. Now, I mentioned meteor showers. That's something that I do a lot of. Every meteor shower, if it's clear, my camera's normally outside. And if you're lucky, out of my 3,000 pictures a night, I might get 1 or 2 that look like this. And it's worth it if you get even 1 that looks like this. So this is a Perseid meteor with its obviously green trail. And I've actually learned from experience that the kit lens is better for meteor photography than the wide angle lenses. The reason being, meteors will be smaller relative to the background if you're using a wide angle lens. Plus, with my wide angle lens only going down to f4.5, the faint meteors just don't show up at all. So I'm lucky I don't even get any meteors if I shoot with the wide angle lens. The kit lens is the sweet spot, because you get a fairly big chunk of sky. Meteors are random. You've no idea where one will happen. And if you've got a big chunk of sky in your field of view, you've got more chance of catching one. This has been cropped a little bit, so you get more sky in than this, but I cropped it because it's such a beautiful meteor, and this is the plow, and it just such a lovely picture. Now, during a meteor shower, you hear a lot of people talking about the radiant. So, for example, in August, when we have the Perseids meteor shower, there is a radiant. And basically what that means is if you track back the path of the meteors, it seems to come from that point in the sky. But for years, I kept seeing articles telling people to point their camera at the radiant. Not the best place to be. Meteors will occur anywhere in the sky during a meteor shower, literally anywhere. If the radiant is higher up, then you get more chance of kind of catching more meteors, because if the radiant's at the horizon, you're only going to get half of the sky full of meteors. But the higher the radiant gets, the more meteors you're likely to see. But during the Perseids, meteors can occur absolutely anywhere in just the whole sky that you can see, basically. But the further away you are from the radiant, usually the longer the meteor tracks are, because they all seem to be radiating outwards. So if you're looking this way, you're seeing the shorter track meteors, and they just don't look as good on camera. So I tend to point my camera 45 degrees away from the radiant. I generally have it kind of the highest ISO I can get away with, and I usually do 10-second shots, because if you do a really long exposure, basically the background sky carries on brightening throughout the exposure. So if you've got a faint meteor, you lose it in the rest of the exposure. That does mean you take a lot of pictures though, which is why I do them in JPEG, because otherwise I would fill every hard drive that I've got. So this is another example of a meteor, which again has a lovely green trail because it's a Perseid. Other showers have other characteristics. I don't know if this video will work. Oh, it does work. Normally, if I copy something across from a memory card, the video doesn't work. When I'm shooting a meteor shower on continuous, it's really important that if you see a really bright meteor like this one, that you don't stop taking pictures, because a bright meteor or a fireball can leave an ionization cloud behind. You can see that I did touch the camera to review this, which is why all these pictures have 2 stars in them. But basically, over the next 40 minutes, that ionization cloud just dispersed. And if I'd been shooting with a wide angle lens, I would not have got that. So yes, this is noisy because it was a summer's night and there's more noise when the temperature's warm. But the fact that I've got this kind of ionization cloud is really cool. So that's why I shoot on continuous even after I've seen a bright event. So shoot on continuous and just painstakingly go through all 3,000 pictures the next morning. But it's worth it when you get something like this. So this is a really bright display of the Aurora Borealis, or the Northern Lights, taken from a field a mile outside of my village in North Oxfordshire. We're heading back towards solar maximum again, where the sun is more active, and the more active the sun is, the more aurora displays we get that are visible further south. This picture went crazy online, as you can imagine, because from Oxfordshire, and it was one of these kind of aurora displays that caught people by surprise. But because I spend a lot of my life hanging out in fields with my camera, we happened to be in the field thinking there was a chance it might happen. So a lot of people missed this, and this is just amazing. But this was taken with the kit lens. One thing that I did wrong, obviously in Oxford, I don't get the opportunity to photograph displays this bright often enough to really hone in the perfect settings. But the pillars here are quite smeared. Aurora is not static. Like generally from North Oxfordshire, aurora needs a longer exposure because it's generally quite a faint thing from this far south. But if you get a really active display with pillars visible, they're moving. So if you do a 20-second shot like this one was, that you get smearing going on because it's moving quite a lot. But despite that, I still managed to get this incredible time-lapse video, which, you know, obviously went crazy online because this is Oxfordshire. You don't expect to see this from Oxfordshire. I have to confess, I cried when we saw this display because it was so unbelievably beautiful. So done with the kit lens. Everyone said throw it away. Don't throw it away. You can do some great stuff with it. It's still one of my favorite pictures and videos that I've ever taken, and it was with the kit lens. Now, moving on to some Milky Way photography, because we are heading into Milky Way season now. This picture here is one of my favorite Milky Way shots, and I've exposed it for longer than I told you you should expose a Milky Way shot for, because I was actually trying to take some star trails, but the star trails didn't work because too much traffic came through and ruined the pictures. But the single shot was lined up perfectly with the Milky Way. That was complete accident, and it's ended up being one of my favorite shots. So if you zoom in, these stars are a little bit blurry because it's 30-second exposure. I would normally do 20, but that's with the kit lens. So that's how much Milky Way you get in there. But with the wide angle lens turned on its side, you can get much more Milky Way in. So for Milky Way photography, I do find the wide angle lens is really good. There is a lot of noise in these pictures, but this is a 10-year-old camera. It's a 10-year-old entry-level camera that suffers with noise anyway. Even on a cold night, you get noise, but it's still Milky Way, and this was taken at the end of October. Everyone talks about Milky Way season as being June and July, but actually throughout August, September, and into October, you can still get Milky Way shots. So, you know, don't be kind of guided by people saying, "Oh, Milky Way season's over already." Just take. You can see the Milky Way all year round. It's just certain bits of it are better at different times of year. Now, with the wide angle lens, if you've got something in the foreground like farm buildings, it really kind of adds scale and a bit of context. And I know with the wide angle lens, the Milky Way is a really small kind of feature within the field of view, but I really like that. I like both. I think it's good to do a mixture of all of those different things depending on what landmarks you have and where you place yourself in front of them, really. But one thing that I've mentioned already is stacking. I'm going to explain what that is in one second, but first of all, stitching is another thing that we can do. The Milky Way spans the entire sky, but obviously with the kit lens or a wide angle lens, you can't get all of the sky in at once. So what you can do instead is just take overlapping shots and then stitch them together. I use Microsoft Ice for that, and then you end up with this beautiful arched Milky Way. And this is my village. I made the effort to go to the top of the hill and get all of that in. So I turned the camera into portrait mode. The wide angle lens has such a big field of view that meant I got everything in there. And it's just like we have a lot of light pollution to the south here, Oxford Airport and Oxford City and industrial estates, but still this amazing arched Milky Way effect. What I find interesting is that this picture was taken from the top of the hill. 2 days later, I took this one from in my garden, and there's way less light pollution showing up in this one. And that's just down to local conditions. The sky was just that bit better 2 days later, plus these trees were masking off some of that really bright light pollution. So as much as it's painful not to get all of the Milky Way in, if you have a lot of kind of horizon light pollution, sometimes just getting a big old tree in there is a really good thing. This tree is now gone. We got hit by a tornado on Halloween and that took that tree out. It's not our tree, but it now means that we have much more sky visible from our meteor cameras, so every cloud has a silver lining. But again, just stitching, these are single shots, these are single 20-second shots all stitched together to create this arched Milky Way effect. I've got two panoramas here taken when the Milky Way is going directly overhead. So when it does that, the distortion at the bit above your head means you can't get the arched effect very easily, but you can do these straight letterbox panoramas. Both of these panoramas were taken with the same camera, but the top one was with the kit lens doing 20-second shots at the lowest f number, f3.5. And this was when my 50mm lens was still new, so I was still shooting at f1.8 because I was excited and could, so I did. But it just shows you that even 10 seconds, it's like half the exposure time, but because of that f number and the fact that it's kind of zoomed in on the sky more, there is so much more detail in this shot than this one. Yet there's loads more pieces to the panorama because you get so much less sky with the 50mm lens, but you can stitch them together like that. And the 50mm lens is so worth having for doing this because it really does pick up so much more. And this one is done from my garden where there's more light pollution. This was done in St. Ives where there is no light pollution to the south. So it just shows you that just having that extra F number capability can really bump up what you can catch. The noise level is real in both of these, but given the equipment, I'm still happy with those pictures. Stacking is something slightly different. And when we stack, what we're doing is increasing the signal to noise ratio. That's the technical term for it. So what the heck does that even mean? Every camera and every electrical thing has an inherent amount of noise in it, and the exact amount of noise is based on your camera settings, whether it's hot or cold, and also the age of your camera, all of those factors. But the noise is completely random throughout the picture. When you take a photograph of, for example, the Milky Way, the photons of light of the Milky Way are not random. So if you take 20 pictures each of 25 seconds and use software to kind of layer them on top of each other, it's called stacking. You don't have to manually do it. You just chuck the pictures in. I use Sequator for this, and it stacks them for you. Some of the noise gets averaged out because that's just a random thing, whereas the Milky Way is not random. So you get way more Milky Way in the picture and less noise in the picture. So it's a win-win, really. There are very few places in the UK that you can do really long exposure times with a wide field lens without getting some sort of light pollution. So it allows you to adapt your settings for your sky conditions and then build it up, and then you can end up with a 5-hour exposure time if you want to. You can just keep going. You don't need to. For the Milky Way, even just doing 10 of these would have been enough, but just 20 of them, great job. It really makes a difference. What we did in Dorset in September, it was the darkest kind of Milky Way sky that we'd ever been. It just looked so stunning. We did a combination of stitching and stacking. Now, this is not something I expect you to go out and try and do as a complete beginner, but it just shows how powerful these techniques are. So this is a 12-pane Milky Way picture. This was taken with an astro-modded camera, and that means there's more color in these regions of the Milky Way because they are redder. There's all these deep sky objects that look very pink there because they're also rich in those colors. But what we did is take 7 lots of 20 seconds of each of these. It was on a tracking mount, so it was a 50mm lens, but we did it for 20 seconds, and then stacked them all together. And then once we'd got each pane stacked, then we stitched them together. And then I did the processing, which is just as important as the capture. And then what we got was this absolutely incredible Milky Way shot. My husband and I don't collaborate very often. We did on this one, and he had this set to f4. If he had set this camera to f2, I would love to have seen the result. I'm devastated that we didn't do it at f2 because there would have been even more to see. But actually, him doing it there meant it's not as noisy as some of the other pictures. So, you know, but that just shows you that added benefit of the Astro modded. But that other 50mm panorama that I showed you was not a modded camera, so you can still do this without a modded camera. Now, I just mentioned a tracking mount. What they do is basically track the stars at the speed that the stars are moving across the sky. So we have this little Star Adventurer Mini, which is very good. It was way cheaper when we bought it a few years ago than what it is now, but it's got a little Wi-Fi hotspot and an app so you can control all the settings. If you have one of these, that's great. But it's not always the best thing to have for wide field photography if you live somewhere light polluted. So I love that we have this, but it's quite an expensive piece of kit to buy if you live somewhere where the sky conditions mean you're not going to be able to take advantage of it. I went to one of my favorite spots where I take the aurora pictures from, and with just the standard lens on a static tripod, straight off the camera with no processing, that's what 25 seconds of Milky Way looks like at ISO 1600. When I first got the Star Adventurer and took it down to that field, I was thinking, excellent, I'm going to push my exposure time up to 90 seconds because I can. And I was really disappointed when I saw that actually I'd primarily caught more light pollution than I had more Milky Way. There is more Milky Way here for sure, but there is so much more light pollution there that actually that would have been a real headache to do anything with. So what I did instead, I was determined I was going to do my 90-second shots, having carried that thing to the field. So I took the ISO down to 800. So that compensated a bit for the local conditions, just meant the light pollution was horrendous that night. ISO 800 has corrected it. So I've still got a lot of Milky Way and less light pollution. So it really is a case of just testing the water. But quite honestly, I have used this a handful of times. Most of my Milky Way stuff now, I just take short exposures and stack them. There's also less chance of something being ruined by satellites or a security light as well, or an aircraft if you're doing shorter exposures. So some other stuff I love doing with my kit lens is noctilucent clouds. They are a summer phenomenon that we get here, and we can see them from further south, but only when there's a very bright display. But a couple of years ago, we had Comet Neowise in the same field of view. If you get a bright comet, you don't need a telescope to take pictures of it. And when I found out Neowise was going to be in the northern sky, I was like, please let me get noctilucent clouds and a comet, because I adore comets, I adore noctilucent clouds. And again, I was actually moved to tears when I watched this. I get very excited and passionate about astronomy. But because noctilucent clouds can quite often fill quite a bit of the sky during a good display, again, just single shots, overlapping them to create a panorama, I really need to get this printed because it's still one of my favorite pictures that I've ever taken. If you zoom in on it, there is so much noise in every single fraction of this picture, but I don't care because it's got the comet and it's got the noctilucent clouds, and I think it's beautiful. And I love the silhouettes of the trees as well. So you can do loads of stuff. Now, that comet was so big and bright that actually most of the photography I did with it was just with the fixed 50mm lens on a static tripod, 10 seconds of shot, just nudging it in between to make sure it was still in shot. And then I just stacked 15 10-second shots. So it's not like a huge imaging session at all. You quite often hear people talking about 28-hour total integration time. For bright objects, you just don't need that. So if you do have a nice comet, you can get away with doing much shorter exposures. Now, this side-by-side comparison is showing you what a modded camera and the 50mm lens can do for you. So I'd always had this dream of capturing all of Orion and getting Barnard's Loop, which is this lovely kind of loop of gas that is around Orion, is just full of nebulosity and interesting stuff. I did 78 lots of 60 seconds on this object with my kit lens, and honestly, the result was pretty awful. And my husband had to help me process it in PixInsight to even get Barnard's Loop to show up. You can see there's loads of texture, but the 50mm lens is such a better quality piece of glass, basically, that it straight away gave me a better kind of field. Obviously, it's more zoomed in. It goes down to a lower f number. So we're talking about f1.8, because I was still excited about that at this point, compared to f4. So straight away, you're getting more light on the sensor. Plus, this is a very red region of space. So I use the modded camera, and actually a similar sort of number, 78 here, 67 here, on a tracked mount, obviously, but the lower f number, better quality glass, gave me an infinitely better example. But ultimately, when I'd finished with this, I was still pleased that I'd got Barnard's Loop, because it's not an easy thing to capture. So I think just give it a go. You just accept that there may be some sort of issues with the final quality, but to even have got the Barnard's Loop at all is still pretty amazing given the quality. Need a long exposure time for it, especially a full moon. You're talking like fractions of a second. So as long as you're not jumping up and down and, you know, kind of bouncing around when you take the pictures, you can get a decent picture handheld. Just lean on a wall and breathe in when you're taking it and keep it stable. But handheld, I've managed to get a couple of awesome aircraft transits of the moon. And actually that zoom lens is phenomenal for getting aircrafts when they're like really high up and zooming in on them. If the focus is good, I do this manually looking through the viewfinder. If the focus is good, you can crop it in and get really close to those aircraft. I love the moon. I love 747s. This ticked all of the boxes. And this was the rising January moon, which is sometimes called the wolf moon. So obviously I called this the Airwolf moon because I'm old enough to remember sitting watching Airwolf on a Saturday evening. So I love the fact the exhaust has distorted the edge of the moon there. So again, not the best picture in terms of noise level or focus for that matter, but still some of my favorite pictures. And this has been published. So I quite often find the pictures I think are not the best technically are the ones that have ended up in books. You just never know. With a crescent moon, you need to really underexpose it to try and see any of the surface features. But if you can put it on a tripod and do like a 2-second exposure, then you'll start to capture earth shine, which is one of my favorite things to do with the moon. I just think it's gorgeous. So when you've got a fairly slim crescent, overexpose it, you'll get the rest of the moon completely illuminated there. There's actually a star about to be occulted there as well. And that's just basically light that's reflecting back off the surface of Earth, illuminating the rest of the lunar surface. You can't normally see it that easily without binoculars, but on a picture it shows up really well. And if you've got like a crescent moon with a planet nearby, you can get these lovely conjunctions. Again, zoom lens, just probably 2 seconds, I think this picture was. So really gorgeous, nothing fancy there, no telescopes or anything. There are some deep sky objects that are big enough that you can actually have a go at doing them with the zoom lens. And, you know, given that this was a very inexpensive zoom lens, this is the Rosette Nebula. I did it with the modified camera because it is a very red nebula, as you can see from the picture, but this was just 67 lots of 90 seconds stacked. Yeah, it's not the best picture of the Rosette that I've ever taken, but given that it was done without a telescope, I think it's pretty cool. And there's another deep sky object down here. There are many deep sky objects that are really big, so if you can push your exposure times up on a tracking mount, you can get in and have a look at those. So I'm going to just kind of do some stuff with a telescope as well. If you're thinking of getting a telescope or you have one and you don't know where to start, there are 3 ways that you can take a photograph through a telescope. The first one is afocal, which primarily is what you would do if you have a mobile phone or a compact camera, where you literally can hold the camera up to the eyepiece and take a picture, or put it on some sort of adapter that holds it still and take a picture. This talk is about digital SLR photography, so I'm not going to go into any more detail on this, but you can buy these holders very inexpensively online. And honestly, you can get some really good moon pictures with this. And I've seen people taking pictures of the Orion Nebula with a phone like this as well. So it's a good way to get started if all you have is a smartphone. In terms of actually attaching a digital SLR to a telescope, there are a couple of different ways. This first way is not the best, but it's a good starting point. If you get a T-ring for your camera, it goes onto the digital SLR in place of a lens. So with this technique, there's no camera lens on the camera. But if you have an eyepiece that when you take the cuff off, it's got this threading, that threading will fit onto the internal threads of this T-ring. So you can screw that together so that you're then marrying your eyepiece directly to the digital SLR. So that will then project whatever the eyepiece is seeing directly onto your camera sensor. I quite often see people referring to the mobile phone thing as afocal, and it isn't, because afocal means you've got a camera with a lens. This doesn't have a camera lens. You've got a telescope eyepiece, but no camera lens. So then that will just slot back into wherever the eyepiece holder is on your telescope. And this is a zoom eyepiece, so this gives you loads of flexibility, zooming in and out of objects. It'll get you in really close on the moon. Doing it this way, the focus isn't the best because you are projecting something through another piece of glass, and generally the fewer bits of glass you have between your telescope and your camera sensor, the better the result will be. But it still works really well. It's a great way to get started, and I've done pictures of Jupiter and its moons like that. But by far the best way is prime focus photography, and that is where instead of having the telescope eyepiece, you just bypass that entirely and you screw an extension tube onto the T-ring instead. So with my small refractor that I tend to use for imaging now, I need a couple of extra extensions here to get myself out far enough to achieve focus. And basically, you just then put that in the back of the telescope. So the telescope is now a giant zoom lens. There's no eyepiece, no camera lenses. The telescope is now your lens. So that definitely gives you a lot more flexibility. Now, if you can't take the diagonal off your telescope, you can put a kind of a T-ring with a 1 1/4 inch tube on instead, and that'll slot in where the eyepiece would go. Either way works absolutely fine. The advantage of this way is it's a bit easier to stick Barlow lenses and stuff like that on it. If you want to use Barlows, you can buy these little nose cones with screw-on lenses, or you can buy the whole assembly. I've got a really nice Celestron 3X Barlow that's its own assembly. And basically, if you've got the diagonal gone off your telescope like I have, you're going to need an adapter that takes it from 2 inches down to 1.25 inches. And once you've got that, you can put any lens on here that you want. You can put filters on there, narrowband filters, Barlow lenses, and it gives you a lot of flexibility. So any of these ways of attaching the telescope to the camera will work really well. As long as it's prime focus photography, that's going to give you the best results. So it all just slots in together. And then in terms of camera settings, it's all the same principles that I taught you through earlier on. ISO determined by your sky conditions, exposure time determined by how long you can expose for, i.e. whether your mount is tracking or not. And that leads me on to myth number 3. You need an equatorial mount to do imaging. This is an equatorial mount. They are way more expensive than other telescope mounts. And if you are going to get really serious about imaging, it's very good to have one, because what equatorial mounts do is track the sky, not just like left, right, up and down, but actually allows for the rotation of the sky as well. The sky's movement is quite complex. It doesn't go side to side, up and down. And an equatorial mount, you have it pointing at the north celestial pole, you have counterweights on the side, and then that telescope, once you've aligned it, you can swing to any object and it will track it at the right speed. And these mounts generally you can track at lunar speed, solar speed, or just star speed, really. So they are really good. And I have a permanent pier, so mine's super quick to set up. I just take the waterproof bin cover off the top and stick the telescope on it. But they are really expensive and also very, very heavy. For a much less price, you can get an alt-az mount. And I see so often people being told, oh, you can't do imaging with an alt-az mount. I'm going to prove to you now that that's not the case. There are some limitations to what you can do with an alt-az mount, but you can still do it. You can see this is one I bought recently with some prize money that I won when I was awarded something for the outreach work that I do by the BAA. This is an alt-az mount, so it moves up and down, left and right, and it doesn't have counterweights. It runs off batteries. It will track at the speed of the stars or the moon, and it all runs on an app on your phone. It's great. But if you've got an alt-az mount that doesn't track, you can still do photography. First of all, with the moon, because it's bright, short exposures are all that's needed. So you can do lunar photography with any mount that isn't moving. You will need to nudge the telescope to make sure the moon is still central with your pictures, but it's so easy. It's easy to point at it, it's easy to focus on it, and it's easy to find. And it's a really good way of practicing how to set your equipment up and just get faster at doing that. To focus, just zoom in on one of the craters with the live view screen and just focus the telescope and job done. And you really don't need long exposures to do that. If you want to get Earth shine through the telescope, you can expose for longer, but you don't need long exposures. So moon photography is a really good way to start. Now, as I mentioned before, the rule of 600 works whether you're using camera lenses or telescopes. So if you are using a telescope, just find out what the focal length is. It's normally written somewhere on the side, or it will be in the technical spec in the handout. And use your rule of 600s to estimate how long you can go without getting trailing if it's static. Now, one thing that I didn't mention, when you attach a camera, a prime focus to some telescopes, only a small percentage, you may need a Barlow in place to achieve focus, because it just pushes the focal plane out a bit more. And that's fine if you're doing most things, but for deep sky stuff, that can be a bit of a hindrance, because every doubling in magnification halves the light. So you can see the problem if you're taking a picture of something very faint, then really try to avoid it if you can. But I'm going to show you at the end another telescope that we can only achieve focus with a Barlow, and I've got some great shots with it. One thing that will really help you if you have a telescope, you first of all point at a bright star. If you can get a Bahtinov mask, these things here with this diffraction pattern cut in it, and they cost around about £10. They come in many sizes, and if you take a photograph of a star, when it's perfectly in focus, it will have this perfectly symmetrical pattern. The top one here, the middle line is off center. The bottom line here, that's slightly off center in the other direction. What you're wanting is a perfectly symmetrical diffraction pattern. And if you've got that, take the Bahtinov mask off and anything you swing to will be in focus. I just wouldn't even entertain doing any sort of photography through a telescope of a deep sky object without focusing with one of these, because the atmospheric turbulence is really amplified through a telescope and it's so hard to see whether you're in focus or not. And also, if you're pointing at a nebula, the stars are so faint in those regions, you've got nothing to focus on. So you need to point at something bright first, do this, and then you're good to go. I have more than once done an entire 4-hour imaging run with this still on. So the data is completely unusable. So don't forget to take it off. You'd think after doing it once I would have learned, but no, I've done it twice now. So this is a picture of the Orion Nebula done on my Altaz mount, and it's a 2-second shot because that's the longest I can expose for on our little 70mm refractor. So there isn't really a lot of detail there at a glance. If I can track and do a 90-second shot on an equatorial mount, I'm obviously getting way more detail. But remember I told you about image stacking. If you take those 2-second shots and take lots of them, these were done on the Altaz mount, 2-second shots, so it wasn't tracking. I just nudged it into place each time I took a few pictures. Yes, there is texture in the background. That is purely because most of that picture is dark. Everything's very faint in those regions. So primarily, I'm still getting more noise and no signal. But the bit around the nebula, there's loads of image detail there. And actually, as a beginner, I would have been absolutely made up with that picture. On the right-hand side here is what you can do if you stack lots of pictures with an equatorial. So obviously this is better in many ways because there's a lot more detail there, but this is still good. You know, you've got the Running Man Nebula poking out up here. It's the whole of Orion's sword and it's a good image. So that was done on an Altaz mount that isn't tracking. So that's 2 of the myths dispelled. You can do that. The Pleiades is one of my favorite shots. It's actually quite hard to image with short exposures because the nebulosity is quite faint around there. So you can see on a 120-second shot, you're only just starting to see bits of nebulosity here. There's none to see here. But again, stack 130 of them. Yes, there is way more texture in this shot. That's because there's so little signal in each of those short exposures. But ultimately, if as a beginner, if I'd got this, I'd have been really happy that I'd got any nebulosity at all. Equatorial mount, obviously better because there's more signal coming in each shot, therefore more noise gets averaged out. But still, as a beginner, for the price difference between these 2 setups, this is still a great image to have achieved. So the thing that people talk about with Altaz mounts, the limitation is because they move side to side and up and down and don't allow for the rotation of the sky. If you do long exposures like this one, this is a 60-second shot on an Altaz mount, you can see that the stars are kind of moving in a circular manner. The trails are circulating round. The way to get around that is to do shorter exposures. You could do 30-second shots and they would not have any trailing in them. And the computer software, Deep Sky Stacker, when you stack them, will allow for it and align everything. So yes, if you do super long exposures on an Altaz, you'll get field rotation. It doesn't mean you can't do photography. It just means you need to do shorter exposures. Myth number 4, you need an apochromatic refractor if you're going to do imaging. Refractors are made by having a piece of like a lens at the front of it and then another lens that focuses on the eyepiece at the other end. Early and budget kind of refractors have got a piece of glass and the 3 colors of light focus in a very slightly different place. So when you think you've got your picture completely in focus, you will have these blue fringes around everything. And that is just a feature of the budget level refractor. You can get refractors now, they're called apochromatic, and they've got these extra low dispersion lenses on the front. So that glass is way more expensive, but it means that the 3 wavelengths of light tend to focus better. So you don't get that kind of weird chromatic aberration, it's called. However, I've done a load of imaging with my non-apochromatic refractor that was given to me by a relative a number of years ago. You can see the lens fogged up a bit here, so there's a bit of weird stuff going on, but every star has a violet halo around it. There's nothing you can really do about that. You can try and remove them in processing, but then you'll have a black halo instead of a violet one, so sometimes it looks worse. Whereas with the apochromatic refractor, you don't get that. The price difference is huge between these two. So if you're willing to accept that you're going to have violet halos around your stars, then go for it. And actually, I stacked that the Orion Nebula is really bright here, but not around the outside. So I quite often do two separate sets of stacking to try and preserve some of the detail in the middle. But this is a non-apochromatic refractor, and it was 50 lots of 120 seconds, 80 times 30, blended together, stacked. Yeah, the blue halos are horrendous, but look how much nebulosity is there, and the Running Man Nebula as well. It's really good. Yes, there are those flaws, and actually the light pollution was bad this particular night, so I've got a weird color cast on there. But given the price difference between the two refractors, you know, this is still a decent picture. So as long as you're aware of what's going to happen if you take pictures with that sort of refractor, then that's absolutely fine. There are still some halos around these stars, you know, they're just not blue. It's just a feature of that area. Same here, there's blue halos around every picture, every star on this particular photograph, but actually the non-apochromatic refractor that I've got is 102 mil. The apochromat is only 70 mil. So the bigger apertures getting way more nebulosity in a single shot than this one is. So there are some times where actually some of the things I get on the cheaper refractor I prefer because it's a bigger aperture. So, and I still use this telescope visually all the time. So if that's what you have, just use it. Don't listen to what people are telling you. This is my non-apochromatic refractor, 23 lots of 3 minutes on M31. Yeah, the blue halos are ever present, but it's still a great picture of the Andromeda Galaxy for a beginner telescope. This is a side-by-side comparison of the Horsehead Nebula and Flame Nebula regions. And again, this is an area that as a beginner, I so badly wanted to photograph. And this was a 28-minute total exposure time on my non-apo refractor, and it's a standard non-modded camera. You can see the Horsehead Nebula. The Flame Nebula looks fantastic on this picture. I prefer it to the one over here, actually. I think it's nicer. It just looks good. But having obviously no blue halos around the stars is great, but having that more sensitivity to the red, and also it's a 78-minute exposure, so it's a longer exposure, but you can see what the modded camera is giving you there. So if this is like the thing that you want to image, a modded camera will really help. But actually, if I just push this on the apochromat with just a standard camera, I would still get a decent Horsehead Nebula picture. And I have actually done that with a non-modded one. So again, use what you have. Myth number 5, you can't do photography with a Dobsonian telescope. A Dobsonian telescope, the Dobsonian bit basically refers to the mount. It's a very simple mount that swings round and then the telescope goes up and down. This one does have go-to and it will track, but generally bang for buck, if you have a budget and you're not particularly concerned about doing like fancy imaging, you will get the biggest aperture for your money if you go for a Dobsonian. It's a super simple telescope design, but they are such great light buckets and you get so much light in them. The downside of this is that you need 2x Barlow to focus. But despite that, I've done loads of imaging with it. Just keep the exposures shorter because obviously you're going to get field rotation if you do longer ones. Just 3 times 45-second exposures, an amazing amount of detail on the Dumbbell Nebula. Because it's a 10-inch mirror, it gathers so much light. This is a single 45-second shot of the Ring Nebula. The Ring Nebula is tiny. You can barely see it when you take it with a small refractor. This is a comet, a single 30-second shot of Comet 2013 R1 Lovejoy. And this is a supernova in the galaxy M82 in Ursa Major, just a single 45-second shot. So you can do imaging with a Dobsonian. Obviously, you're cutting half the light down because you've got to use the Barlow, but it's such a big aperture that it doesn't matter. We've done loads of stuff with it. And I've also done a lot of high-res lunar stuff with it using an app called Backyard EOS. And what that does is basically records a video of your live view screen. So you can zoom in ×5 or ×10 on a little area of the moon, take a 4,000 frame video, and then use the same stacking software to just analyze them and stack the best of them. So this is 1,000 image stack, and it looks like I'm in orbit above Sinus Iridum, and the Mount Laplace shadow looks amazing. So that's a Dobsonian telescope. Everyone says you can't do imaging with it. You can. Also, planetary wise, everyone says to me, you can't use a Dobsonian and you can't use a digital SLR. Both of these planetary pictures were taken using Backyard EOS, using a digital SLR and a Dobsonian telescope. And you know what? We have better equipment and better cameras now, and we've never bettered these shots. A lot of your results are down to atmospheric seeing and the location of the planets at the time. In recent years, the planets have been really low down and it's been very hard to get decent pictures. So we've never done better than this yet. I'm sure we will in future years when they get higher again. But it just shows you can do that sort of imaging. I just want to finish off with one more myth, and that is big is better. I think there's a tendency to get aperture fever when you first get into astronomy, but actually, depending on what you're interested in, bigger may not be better. So using Stellarium's ocular view, this just showing the 70mm refractor that I've taken loads of pictures with in tonight's talk. All of Orion's sword will fit into that field of view. I tend to rotate the camera so it's pointing vertically up the sensor, but all of that will fit in. But if you look at the Orion Nebula with the Dobsonian plus the Barlow that you need to focus it, you're basically getting that tiny little square there that would be in the middle of that bit. So I've had people email me before now that have been on my beginners courses and saying, I'm pointing at the Andromeda Galaxy and I can't see what I'm doing wrong. And basically it's because you've got too big a telescope. So the Rosette Nebula fills the field of view with the 70mm refractor. With the Dobsonian, you're lucky to even get the central cluster in the field of view because it's such a big telescope. And that's not necessarily good if you want to take nebula pictures. And with the Andromeda Galaxy, it just fits in. I rotate it so it goes diagonally across my sensor, but all of M31 will fit into that field of view easily. All you're going to get with a bigger telescope is the core. So you're not going to see all the dust lanes, you're not going to see the structure. And if you actually put a Barlow on the 70mm refractor, if it's a good quality telescope and a good quality Barlow, you can zoom in and it gives you loads more flexibility. So this is just showing you the changing field of view. Because the moon and the planets are very bright, the Barlow doesn't affect the result you get. It's actually good. It adds contrast. And if you had the 10-inch Dobsonian, you wouldn't even get all of the moon in one go. So, you know, not always better. This picture was taken with the refractor in a 2x Barlow. And so this is just 70mm refractor. And because I've used the Barlow and then stacked a load of images and cropped it, you can get in quite close onto some of these features. So although you might be interested in high-res lunar stuff and think a big telescope's the way to go, if you've got a big telescope, you can't do the nebula photography. Whereas if you've got a small refractor, you can put a Barlow on it and make it bigger or apparently bigger. So I think having a small refractor gives you way more flexibility in terms of what you can actually image with. I'm going to just finish by telling you the names of the stacking software that I use. There isn't time to go into how to do that tonight, but for the lunar and planetary stuff, all of these are free. Autostacker, actually I use Autostacker 3 now, and Registack 6. And that's what I use for the moon and the sun as well, and planets. Wide field stuff, I use Sequator, and for anything else on the telescope Deep Sky, I use Deep Sky Stacker. They're all very different in how they work, but they're all free and they all do a really good job. When you're stacking, it's better to stack fewer high quality images than it is to stack a load of junk. As honestly, you put junk in, you're going to get junk out again. So in summary, ignore the myths, use whatever equipment you've got and push it to the extreme of its ability. And then once you've decided what you like, you can improve on things. Keep it simple. Don't try to rush headlong into stitching and stacking. Practice focusing the camera and just getting some single shots. And once you're confident with that, you can build on that knowledge. important point here, don't judge your effort by other people's work. It's fine to get inspired by them, but the only person you should be judging your progress on is yourself. So look at what you was doing 3 months ago, and if you're improving, that's great. We're all guilty, like experienced imagers will put a picture online, and I will look at these pictures and think, wow, I would die happy if I took that. There will always be captioned, well, this is a really rubbish effort, but I'm sharing it anyway. And you're kind of like, why have you said that? People say that because the internet is a horrible place, and if there are any flaws in your picture, somebody will point it out to you. So if you get in there first and say, yes, this is noisy, but then I guess it gives you a get out before people are horrible in the comments. But it's great to get inspiration from other people. I still do it on a daily basis, but I don't judge my efforts based on their images, because I might not have the equipment they've got. I probably never will have the equipment they've got. So only judge yourself against your own progress. So thank you for listening. Obviously, I'm sure there'll be questions and I will do my best to answer them. I'm not in a rush to go home. I know we've started super late, so we finished super late, but I will do my best to answer any questions that come up now. And if you think of something afterwards, just drop me an email. My email address was on my card there. So thanks for listening, everyone.
Mary, thank you so much. I think there's been a few comments during that, but this one I think really sort of sums it up. It's from Lucy Rogers. It says, this has been brilliant, given me some hope I can really try this. Others have bamboozled me and out-financed any opportunity with all the fancy gear, but you've given me hope. Thanks so much. And
excellent.
And I love your photos. And that's really what it's all about. It's about helping and encouraging other people to get on with us and have a go at it. If you do have any questions, folks, do put them in the chat.
Somebody has messaged me privately in the chat asking if there's any way to earn from images like these. There are a few things you can do. You can sell prints, but quite honestly, that is really difficult these days because everyone can go and just download a Hubble picture and print it out at home. I do sell prints and I've sold a couple of them, but actually, I sell more prints of my astronomy sketches than I do of my photography because I think we're just absolutely bombarded by excellent astro images on a daily basis everywhere on the internet. So it's kind of, it's really difficult to do that. But the other thing you can do is to try to have a YouTube channel that is in some way monetized. You need to have regular upload schedules and be providing tutorials and stuff like that. And that is not an avenue I've ever been interested in pursuing because I like to just help people and I give away. I don't guard my secrets. If I'm doing a talk and there's something I've learned, I will tell you. So I think I've done a lot of workshops over the years, and it was difficult to even get people to pay to come to the workshops that we used to hold in Banbury because people expect the internet for free off YouTube. So there are some ways that selling prints is really difficult, but in any sort of photography, I think it's difficult. Now, everyone has decent smartphones. They're all photographers in their own right. So it's not really something I've explored a lot because although doing talks and stuff is my job, I don't try to monetize every aspect of my astronomy because I do it for the love of it, not to earn money.
Yeah. Such enthusiasm, really infectious. Love this. Focus has always been an issue for me, so got some tips to get that right. Someone's asked for the last slides again. This is going to go, we are recording this and it will go up on the web so you can see as much as you like again later, once that goes up, probably early next week. Amazing photos, brilliant presentation. I live in the BCT, that's Bournemouth Christchurch Pool Lightbox. If I can't get to Cranborne Traces, it's worth getting out to the beach and facing out to sea. Yes, but get out to Purbeck. Yeah, get yourself out to Purbeck. There's then your nearest light to the south is Cherbourg, 60 miles away. It's absolutely fantastic out there.
Yeah, somebody's messaged me directly about that. As a city dweller, can you actually see the Milky Way in the dark sky? Yes, I live in Bortle 4 skies, which is not that dark, and I can see it every night. From Dorset, anywhere on the south coast, really, that is the darkest I've seen. It was better than the south of France, in fact. It was gorgeous. It doesn't look as colourful, but it's definitely visible. And through binoculars, like you've talked about this yourself, Steve, it's so jam-packed with deep sky objects that You can lose yourself for 3 hours exploring.
Well, that's it. The problem isn't seeing stuff; it's identifying everything you can see. It's lovely. Thanks, Mary. You've inspired me to touch my iPhone back onto my telescope in Banbury Shire. So that must be good.
Yeah.
Great talk, Mary, as always. Well, yes. Really inspirational, Mary. Thank you so much. Thank you very much. Brilliant talk. Fantastic shots. Can't wait to go and try things. Amazing pictures. And you can tell Mary is really passionate about this. Many thanks. And then thank you so much. With that, I'm going to stop the recording anyway. But